Hello, hi everyone. Thank you for being here. Yeah, it's great to be here with fellow testers. I mean, could have been anywhere today, but it's nice to be here. So, big shout out to you guys. Let's start into it. So, let me introduce myself. My name is Arif. I'm the head of QA at FX Digital. Been with FX Digital for about 4 years now. I've been in software testing for about 10 years. But I've been a tester pretty much my whole life. It's an outlet, right? So that's how I see it anyways. I've been involved in video game testing in the early stages of my career, web-based testing, even mobile, and now I'm in the connected TV space. And this is by far the most challenging that I've been involved in, and that's what I'm hoping to dive into today, to show you what it is we do, how we do it, and resolve some of the challenges that we have. These are some of our clients we've worked with. There's a few in there. There's more, but I can't quick show of hands. And this is probably the most ridiculous question, but who here has a television? Yeah, of course, right? So hopefully some of this is relatable to your own experiences. So let me tell you about FX Digital. So FX Digital is a connected TV specialist. That's what we do. We are the connected TV experts. We have an office based in London. We're on Old Street, so not too far from here. We recently opened up in Barcelona, so we are expanding. And we have about 70 people spread across numerous key disciplines. So you can see we are involved in project management, product design, engineering as well, so we have developers. And of course, the two key ones, quality assurance and quality engineering. And those are what I'm going to be talking about today. And yes, we do have two separate departments for quality assurance and quality engineering. QAs, we work directly with clients on client projects, whereas QE provide the tools to help QA be more efficient in their jobs. The way I see it is QE is what DevOps is for devs, basically. So QE for QA is kind of what DevOps is for devs. So just want to share some of our testing ethos. We are connected to TV first, so TV apps are either built natively or for web, and we always try and focus on testing on TVs where possible. We avoid making modifications to applications, so we test on applications that are as close to or as close as possible to the end user experience as well. So we try and use production content where possible rather than manipulating test data to make things work for our tests. Basically, that's the idea of that. And we test on real devices, always try and really test on real devices. We try and avoid simulators. We have used them in the past, but they're just not representative to what the actual experience is for a real user. It's just not accurate. Simulators are using memory from your devices, so if you're running it on a really powerful computer, video playback will be fine. So yeah, we try and test on real devices for the real experiences. Cool. I'm going to try something. I've never tried this, but I hope this works. Take out your phones, scan this QR code. I've got a question for you. I hope this is going to get out of the way. So it's just in the top corner as well. Here's the question. When was the last time you purchased a new main TV for your living room? Okay. We're getting some responses going through. It's working. Okay, excellent. Nice, okay, yeah. So a lot of more than 4 years ago. Right. Cool, thank you everyone for participating in that. Kind of what I was expecting, so thank you. This wouldn't have made sense if it was the other way around. So this is actually one of our challenges that I'm looking to dive into today. But before we do, I want to show you something. This is a list of some of the vendors that we work with and the devices that we have to care for in connected TVs. So unlike mobile phones, where it's iOS and Android, we've got so much to deal with here. Where do we start, right? It's always been a big challenge for us. And the thing with all these different vendors is that they have their own operating systems as well, which means their own certification requirements as well. So how do you get an app to work across all this? These are some of the challenges we're diving into at all times. It makes it very difficult just to understand, Samsung perhaps they want your app to start within 15 seconds from cold start. Somebody like LG might turn around and say, no, we want that to be 10 seconds. But we want the same app across both platforms. So it becomes a real challenge. The other thing, with all these devices, every year it seems as though the software is no longer supported, not supported, but updated. It looks like the software updates are only available until the new model comes out, and we're kind of stagnated with devices that are running older libraries and compatibility Chrome drivers for older versions. So we have to make new apps that are compatible for said devices because, like you just saw, you haven't updated your TVs for more than 4 years in most cases, right? Cool. So we have one word that summarizes all this: fragmentation. Devices are all over the place. Let's dive into it. So, quality across CTV, it is tough. Clients want to target as many platforms as they can. They want to get as many subscriptions to their applications as possible. They don't care where it's coming from, right? So this has become a real challenge. Looking back at the big list of all the devices, they want features that are available to be across the board with their applications. So if a newer TV has a feature to, customize subtitles, let's say, they want that in their app. So we have to think about challenges on making such a feature available for all devices as well. And it's the same for the audience as well. They've brought a TV, perhaps a couple of years ago. They expect their applications to just work on it, right? They must have spent like hundreds of pounds, 55-inch 4K TV a couple of years ago. Yes, the software is not being up to date, but they expect the applications to still be of a high quality and available. What makes testing on TV different from browsers and mobile? So let's dive into this. I'm hoping this will give you some insight as well. So firstly, check this out, guys. So this is the BBC website, the HTML doc for the BBC website, compared to one of our apps created in Lightning.js. Lightning.js is a framework, a library that we use to optimize TV apps for said platforms. Yes, this is great. Like you can see all the classes, all the selectors, which makes it great for browser-based testing, right? Selenium, your playwright, you can pick out these elements and you can create test cases. But how do we do that here? We don't have a DOM, and this is the way Lightning.js renders information. There is no DOM, again, to make it optimized for said platforms. A lot of these TVs and set-top boxes, they don't have that much memory, so we're in a position where we have to, we can't load up this, basically, because when it comes to playback, we just are in a space where we've run out of memory. So the way Lightning.js works, just in a nutshell, is it draws things to the canvas. So it doesn't structure a web page as you typically would. We have to take on these challenges. Another thing I want to talk about is a keyboard, because there's a remote control. Of course, you've already used remote controls in the TVs. So when it comes to browser-based testing, yes, you have a keyboard, you have a mouse, you can click on elements, you can interact with it. Great. But if you try and do that with a remote, there's a lot of prerequisite steps. So to interact with a button on a TV app, you probably have to scroll down a few times, right? And then press the select button. So this is extra time that's been incorporated into test cases going forward. Keyboards as well. Have you guys typed on a keyboard with a remote? It's not the best experience, right? And although a lot of keyboards are supported on TVs, we test with real remotes, because that's the way users are going to be using it. I mean, how many people here, quick show of hands, sorry, have a keyboard attached to their TV at home? Oh, nice. Okay, there's two. It's nice. And I guess it's because of this, right? So you can type easily into fields, right? Yeah, and I'm going to talk about something we added recently to our automation, a keyboard navigator. This is a little picture of how we do it. We've mapped out the keyboard layout from devices, so each device that we're targeting has its own separate layout. And instead of, in our test cases, we say, press right, press down, press enter to just type one letter. We can actually specify the string. It separates the characters in the string, and provided we tell the framework where the focus currently is, it will do the navigation and look for those characters on the map, and it will map it out and execute it as well. Yeah, nice. So here's another thing as well. Documentation for set-top boxes and TVs is just not available out there. They're just not as common as your phones or browser-based stuff. So yeah, it's very scarce. We have to, somewhat dig into stuff ourselves. The TVs and set-top boxes, because they have their own operating system, a lot of them are very restricted. I don't think manufacturers want us to know how to dive into it. Probably one of the reasons why I'm guessing is for piracy, right? You don't want to be able to take content from a TV and be able to legally stream it, right? So there's all these factors we have to take in. Our quality engineering team has been reverse engineering a lot of this as well. So yeah, our QA team is a bit like our R&D department as well, in some sense. They have been understanding what data is available from exposed API endpoints and sort of reverse engineering what we can do with this data. So we've incorporated that into our framework. We even have a input-output Arduino board as well attached to some devices. So these are the older devices that have infrared blasters. We are able to capture the infrared code when we press the button, and we put it into our framework. So if we say in our test case press the right button, you'll know which IR code to send based on what device you're running on. So it's a framework that needs to work across all those devices. We call it device parity, basically, having the same test or the same app, but running across multiple devices. And again, QA are always working with QA's needs as well. And when it comes to documentation, because we are a niche, it's very important to keep up to date with all the documentation that we're doing, everything we're researching and finding. We're trying to make sure we have it in a safe space. Cool. So testing on TV is more physical, it's more manual, it's less supported, but sometimes we have to build our own solution, and it's the only way forward. And that's exactly what we did. we managed to figure out how to automate on connected TV devices. So we have created a visual-based automation framework in-house. So manual testing is still very important. For that user experience, right? We need to test things like the video and the audio is in sync. We want to test the playback quality as well, which might be tricky with automation. We are researching all this, by the way, like how we can get these sort of manual tests into our framework. So coming soon, hopefully. And there's things like performance as well. So when you're navigating the TV app, when you press down, you see the scroll animation. How smooth is that, right? It's still, all that affects the user experience. So yeah, very important that we still do manual testing on CTV. But we do need a way for it to be more efficient and more streamlined. And yeah, like I said, there's a lot of prerequisite steps when we're trying to interact with a button on the TV. So yeah, we definitely need this streamlined. So what we've developed is our own visual-based in-house automation framework. It's based on Cucumber, and we're using shared steps for parity between all these devices. So if we say, press the enter key on our test case, the framework is detecting what device you're trying to run this on, and then it executes the right command for the enter key for that said device. So yeah, it can get a bit tricky, but yeah, we've programmed it in a way so it works. Yeah, it actually works. Cool. So getting a screenshot from a TV or a set-top box. So like I say, a lot of these devices are very strict and locked down. We do use reference images from designs, and we compare them with screenshots from the real devices. So we call this ICS, Image Comparison Service. So how do you get a screenshot from a device that doesn't have HDMI output, right? So like Samsung TVs, LGs, they've got inputs. Yeah, you can plug in devices, but you can't really take anything out. Our QA engineers, they have found a solution for our TV apps. Can't really talk about it too much, it is top secret stuff. But it works, yeah, and getting that to work across all the different variations of the devices, all the different model years, that's been a real challenge. But the approach has been to keep it command-line based. And one of the reasons why is so we can get the CI/CD pipelines to execute these commands as well through the framework. For devices that do have a HDMI out, yes, we use capture card. The capture card also is a special capture card. It's got an Ethernet port, so we can communicate again through the CI/CD pipelines to request it to take screenshots from said devices. And this is a little example here from one of our apps where we have the image over here for the 10 CD. This is from the design, and this is what our framework has captured from a 720p device. So it's a little bit more blurry, and also the color is not the right shade of blue. And our framework has produced this sort of heat map down here, and the bits in red are the areas where it's detected that there is no match. So if this is too high, it will fail to test case. And that's been our approach to checking our applications across the board. Cool. So yeah, just a quick one here. For video player testing, we've recently purchased a really wide-angle camera, and we can with this approach, it's very high quality as well. I believe it does up to 4K. We have mounted the camera quite close to the TV. So most other places would have a camera really far away from the TV to capture it, but you know we don't have that space. So this has been our approach. It warps the image into a big bowl, but our QA engineers have again reverse engineered how to make a warped image appear like a normal 16 by 9 image. So yeah, it's a lot of research, a lot of stuff has been going on in the back end, but yeah, these are our solutions. And yeah, there's a lot more to cater for televisions. So if you think about this, guys, so TVs are getting bigger, and bigger TVs produce more heat, right? So we're in a really crazy situation where how do we get this heat out of here? We need to keep things cool. TVs aren't really designed to be left running for days and days as well. And you can probably see up here, we've mounted these small fans above TVs. The idea for that is just to push air around the room so we can get it out to these air conditioning units and get the heat out there. We have temperature control in the device lab that we have, just to make sure things are stable. Yeah, so lots more to cater than just the devices themselves. There's the office needs as well that needs to be considered. For automation, we have added smart sockets to every device that we have. And these are great, these are a lifesaver. So a lot of these devices, again, they're not designed to be left running 24 hours a day. With this approach, because they're smart sockets with Ethernet capabilities, we're able to trigger a reboot of the device. And this is great for pipeline runs. So before a pipeline starts in the evening, we do a quick reset of the device, make sure it's freed up any unnecessary memory that was there. It's all in a state where it's now ready to go. So yeah, that's been our approach. And then yeah, we've synced up everything to Slack bots in our Slack, our internal Slack. So we get alerts for temperature spikes, and we also get alerts for the results that come through. And the way the QE guys have put this together has been super useful for QAs. When the QAs come in, they can just look at the test cases that began failing. So in this case here, it's just these 5. So QA can come in and know exactly which 5 test cases they can focus on to understand what's happened in the run. And yeah, just some stats here. So we run over 40 devices daily. We've saved 551 days in the last month. We have around 75% coverage, and we run 250,000 test cases every month. So yeah, lots going on. Here's a picture of our automation test lab at night, just doing its thing. It's quite nice just being there and seeing it in action. Yeah, pop around to Old Street if you're interested. And I'll leave you with this, sorry. So, great streaming experiences don't just happen, they're engineered. And that's the FX Digital touch. So next time you're streaming something on Netflix, think about us. Think about what we're behind testing here. Yeah, think about FX Digital. Thank you guys. That's our LinkedIn. You can search for me as well. So from Mohammad Arif, you'll find me. We have recently started a YouTube channel as well, so please give us a subscribe there. Sorry, I know I've gone way over.
Yeah, we don't have time for Q&As, but Mohammad is going to head upstairs for a workshop that he's hosting now. Do you want to tell us a bit about it?
Yeah. Come on, we're gonna go and sort it out now. So yeah, it's the last workshop for the whole event, right? So come and join us. We're going to be playing a bit of Jenga, but with a twist. Hopefully you'll learn a thing or two from it. So yeah, please come on up and check it out. Thank you.
Thank you.